have a image of the food chain and the food web. The food web image is on the left side of the screen, and the food chain image is on the right side of the screen. Open ocean food chain involves plants, consumers, and plants to plant eaters to meat eaters. It's mainly about the animals of the ocean since animals live in the ocean. And are the the microscopic plants are at the first level of the ocean. Mostly all of the herbivores and all of the herbivores and divivores are on the second level of the ocean, and the carnivores, which are the mammals like us, they are on the third and fifth level of the ocean.
Maybe. There it is.
Now to my graphs, my favorite part of my presentation. All right, the kilometer graphs. Here on the left side, we have the southern hemisphere graph. As you can see, the green line on this graph is much higher than the northern hemisphere on that graph. The green line represents temperature, and the blue bars underneath represent precipitation. In the ocean, as you know, we don't get much precipitation because you can't really rain or snow in the ocean. But for temperatures in the southern hemisphere, the temperatures are much higher than the north hemisphere. I believe that the temperatures are much higher in the southern hemisphere because that's where most of the animals are where they live. And most of the time where people live is going to be much hotter. And in northern hemisphere, it's mainly where we are able to like go to the beach and stuff. And so I don't think that that would mainly be where the highest temperatures are. The non-material terrestrial natural resources that we have in the open ocean today is drinking water. Now we have drinking water because we, of course, are surrounded with water in the ocean, and we also have nutrients availability. The nutrient availability comes from the fish. We also have many plants down there, starfish, and as you know, if you've seen the movie Reef or one second. Okay, sorry about that. I am also on my peak meeting, so I had to kind of transfer for a little bit. But to come back, the availability, as I was saying, if you know the movie The Reef or Nemo, you would see that many of the sharks eat fish. So that's a lot of where the nutrients come from. And we also have much soil, which is where most of the fish and starfish live. And now for my last slide. I know you guys are kind of sad, but it's okay. I'll be back eventually. And here are all my works cited sources that I have used.
All right, thank you, KK. I am going to make a couple of points if it lets me scroll back a little bit um, to just clarify. You do actually get a lot of precipitation out here. I'm going to assume this is probably centimeters, so you're looking at 70 centimeters or roughly 35 inches of rain for that month. So you can. Your temperatures are going to be based off the angle of the sun, not necessarily how many people. Now we do get urban heating um, with a lot of what is it called? Pavement and concrete, stuff like that. That's why it's always warmer in downtown Colorado Springs versus if you were to have a house like closer to Falcon. So do keep that in mind that this is based off angle of the sun. And then there is actually quite a bit on your northern or southern hemisphere one. There's not a whole lot, but definitely your northern one. Your resources. I'm just going to caution you guys now if you ever go on, any survivor shows, salt water is not drinking water. The process of desalinization, which is taking the salt out of the water, is extremely difficult and still really expensive for right now. It's basically reverse osmosis. So if you remember from your biology classes about osmosis, you have to go against osmosis.
That sounds difficult in itself right there.
It is. And I mean, it can be done, but the resources for that at this point is really expensive. You do have a couple of third world countries that do desalinization for water, but it's because they literally have no other choice. They have so much giardia and other stuff in their water that they have to clean their water and use salt water. So a couple places it's not an option. Another resource out here would be your fish, your whales, your tuna. I mean, tuna's a fish, but all of that type of stuff. Your sea turtles, tourism for everything that goes out there, all sorts of commercial fishing and stuff too. So keep in mind that. But I did want to stop you on the drinking water. We'll talk about it a little bit more a couple units from now, but we have very, very, very little drinking water on our planet. But otherwise, very good. I didn't even see that. Very nice. I love that dog. All right. Let's do a couple more. Keenan, you want to go? Yeah, totally. I know. And I'm going to mute myself so that way you don't pick up feedback.
Alright, so this is the taiga biome. I don't know. How do you say it?
Taiga.
Oh, taiga? Okay. So the taiga biome is pretty much located in the northern hemisphere, places like North America, Russia, China, and Japan too. A little bit. So the climate in the taiga is typically cold with lower precipitation rates, and it's usually just snow and rain precipitation-wise. Winters are a large majority of the year and usually have below freezing temperatures. Summers are also short and have little to no frost in them. The soil is also highly acidic, and in more humid areas is usually leach spotosols. This usually means leaching of iron, aluminum, and organic matter from the A and B horizons. Some more primary characteristics would be, like for the vegetation, it's mostly trees or coniferous trees, and those trees consist of typically spruce, fir, pine, and larch, but spruce is the most common one in the North American area. The primary animals would be things like foxes, lynxes, bears, and minks, squirrels too, but like I'd say the most like deadly or dominant animal would be wolves. Here's the food chain and the food web. The food chain is on the left and the food web is on the right. Apparently that image was not that blurry when I found it, but it's also cut off. My bad. But it starts with like different types of vegetation. It moves towards moose and elk, which go towards the wolves. I think. I'm pretty sure it's the wolves. And then the trees also go to insects, birds, and smaller rodents, to bigger birds and foxes, to something else down there, which I can't tell what it is, but probably some bigger predator. And then for the food web, we have the vegetation at the bottom, into decomposers, into the smaller and more passive animals, into the more deadly animals, and then at the top into anything above that, pretty much. And then since it's only located in the northern hemisphere, there was only about one climatograph. The others looked pretty similar to it, but typically temperature is the warmest around June and July, and coldest in January and December. There's also a higher rate of precipitation around May and June than there is in any other month. So some non-material terrestrial resources that can be found would be water, lumber, like different terrestrial animals, and I don't know if fish count.
Yeah, fish count.
Okay, and fish, and then fur as well, if you, yeah, from animals and stuff. And then I forgot to cite the images, but these were the primary websites I used. And that's a black screen.
That is a very black screen. Correct. All right. All right. We'll do one more. Ashley, if you want to go ahead and go. Do you want me to pull it up, or do you want to share your screen?
How do I share my screen? You can pull it up.
Okay. And you can just tell me to click. Here it is. Give me 1 second. It's loading. I think. There it goes. There it goes. My computer was not ready to come back from break. All right, so just tell me whenever you want me to click next if I don't pick up on a hint. All right, you should be good to go.
Okay, hi everyone, I'm Ashley and I'm doing a presentation about coral reefs. Next. Here's the location of where coral reefs are located. All the red dots. And here are some characteristics of coral reef salinity. Globally, corals occur in a salinity range between 30 and 40 PSU, although coral reefs also thrive in exceptionally high and low salinity conditions. Depth, coral reefs can be found at depths exceeding 300 feet, but reef building corals generally grow best at depths shallower than 230 feet. The most prolific reefs occupy depths between 60 to 90 feet, through many of these shallow reefs have been degraded. The turbidity, I was actually confused on this one, but it shows how it affects the coral reefs. I just said that smaller coral reefs organism due to the settling of suspended sediment reduce light availability for coral and seagrass photosynthesis due to increased turbidity favor the growth of microalgae at the expense of corals due to high nutrient availability. Next slide. Yes. More characteristic, the nutrient availability. Coral reefs are found in oligotrophic waters, which are poor in nutrients such as nitrogen, phosphate, and possibly iron. In spite of this, coral reefs exhibit high gross primary productivity rates. And then for the layer, um, I just said a coral reef is made of thin layers of calcium carbonate. For temperature, many grow optimally in water temperatures between 73 and 84 Fahrenheit, but some can tolerate temperatures as high as 104 Fahrenheit for short periods. Most reef building corals also require very saline or salty water, ranging from 32 to 42 parts per thousand. For the food chain, food web, the first one is that the producers, the phytoplankton on the ocean surface, the primary consumers, the coral, sea turtles, and fish, the secondary consumers, the sharks, anemones, starfish, barracuda, jellyfish, sea snakes, and sea slugs, the scavengers, the fish. And for the trophic level, in a coral reef, describe the feeding position of the plants and animals that makes up the ecosystem. Plants which are able to create their own energy are primary producers. Herbivores, creatures that eat primary producers, make up the second level. Carnivores occupy the final. And here's the northern hemisphere. This is the only one that I found. And this is the southern hemisphere, and I'm not sure if this one is correct because I couldn't find any of them. It was hard to find. And for the non-mineral terrestrial, coral reefs are some of the most diverse ecosystems in the world. Coral polyps, the animals primarily responsible for building reefs, can take many forms: large reef building colonies, graceful flowing fans, and even small solitary organisms. Thousands of species of corals have been discovered. Some live in warm, shallow tropical seas, and others in cold, dark depths of the ocean. And here's my works cited. And that's it. That's all I have.
All right, thank you. I am gonna comment on a couple of things if I can find them. You said you weren't quite sure about turbidity. So, if there's a high amount of turbidity, that means it's cloudy looking instead of clear, like crystal clear water where you can see everything.
Yeah.
It's usually some sort of silt or dirt, and so it covers those reefs, and they're not able to feed or get sunlight. And so that's where that obnoxious macro algae and stuff can grow. This stuff was good. The salinity, there was something else. Yeah, it's really hard to find a northern hemisphere one for you guys. This is a southern hemisphere one.
Oh, that's southern. Sorry.
So yeah, it's fine. Almost all coral reefs, for the most part, are pretty much near the equator. So you do get some shifts based on mountain shadow and like other topographic effects, where it will do that. So when I was helping Leland with his graphs, he ran into the same issues you did. This one is probably correct as well. Um, at the Great Barrier Reef, so that looks right. The only thing it was missing was units. This should have been non-mineral resources, not terrestrial. It's not land. So things like, I don't think Leland mentioned this in his either. A lot of reefs and corals get used for like antibiotics and medicines. Things like that is one way. Obviously, tourism. I mean, even Mr. Delhoy next door goes scuba diving and stuff. So that brings in a lot of money. Um, and just there are some other things there, the fishing, things like that. But otherwise, your information was really good. So
Miss
very
B,
nice. Yes, what's up?
when I did the when I was talking about the natural resources, I did say coral, but I didn't say in antibiotics. I said
Yeah.
it when I used it for the fractures, or they
Yes,
used it for the
yes, you
fractures.
did. Yeah. I'd totally forgotten about that until you said that. So that was a good one.
That's not the same though. Antibiotics is different, isn't it?
Yes, antibiotics is like the stuff you take to get rid of like strep throat, for example.
Mm.
Yeah.
I didn't come across anything like that.
hmm Yeah, and like I said, we'll be doing a documentary like middle of next week, at least parts of it. And I think I don't remember if that's the part we're gonna watch or not, but they do talk about that a little bit.
Okay.
All right. Any other questions? Anything like that? We're gonna do. While I transition over, get some of your questions in here. Remember, I'm looking that you have 3 of them. A couple things to make sure they have that they make sense. I was reading through them. Reading through them the other day, and there was a couple of them. Like KK, come on, how would you describe temperature? I think you can come up with a little stronger one than that, or at least be more specific. What about that biome of rivers and streams did you want more information on the temperature about? There was one, I can't remember. I feel like it was early on. I should have highlighted them. But make sure they make sense. That's what I want to ask. Like, if you're asking that question, make sure there could be an answer to it. So you might have to get a little bit more specific. Not to call you out, KK, but that was just the first one I could see in tiny font. All right. So you guys should have. Sorry, I've got so much open right now. Your packets out. We're going to talk about biogeochemical cycles, and I'll be a little bit honest. It's probably one of the more tedious things that we will talk about is in terms of how interesting it is to learn or how relevant it is to learn. Even though it is relevant, it's just kind of one of those things that's hard to correlate to sometimes. But the nitrogen especially cycle, you get pretty heavily tested on in the spring. So open up your note packet to, open up your note packet to this page. This is where we're going to start, and we'll feed a few more presentations in throughout the week. Where's my PowerPoint? Section 4. So section 4. It's quite a ways in there. The good news is I think there's a lot of pictures. Yep. So when we talk about biogeochemical cycles, we're talking about water cycle, carbon cycle, nitrogen cycle, phosphorus, and I feel like I'm forgetting one, but whatever it is, we're going to go through it and how it moves around on Earth. You good, Jamal? Yes, I do. Javea, section 1.4. All right. So we're going to be looking at nutrient cycles too, as well as that, and that's a big part of the nitrogen and phosphorus cycles, and how they move through air, water, soil, rock, living and dead organisms, and then how it moves through the ecosystem, biosphere, all of that. So. good to move on? I'm going to try and speed through a little bit. All right, so this is your carbon cycle. You have your CO2 in the atmosphere, cellular respiration, and photosynthesis. Hopefully you remember some of that from biology and what it is. Some of you have already mentioned detrivores in your food chains and food webs. Those are found down in the soil or the detritus. And then obviously fossil burning fuels, stuff like this. This is a pretty simple carbon cycle. Carbon is related to the element of life. If it has carbon in it, that's what makes it organic. We're not talking like organic food at the grocery store, but organic meaning like living. And a lot of that is like it says up there. The reason we consider that is because it is 100 times greater in living matter, or found 100 times more in living matter than it is throughout the rest of the earth. So in order for life to continue, in order for more babies and little puppies and all of that stuff to be born, carbon has to continually be recycled. For all we know, you could be part Albert Einstein. Do you guys remember what abiotic and biotic are? Huh? At least you're honest. All right. So there it goes. Oops, just kidding. So when we talk about carbon in the abiotic environment, we're talking about like the open ocean, for example, like KK was talking about. We're going to talk about carbon dioxide, and also carbon dioxide dissolved in water is generally referred to with that HCO3 minus. We could go into the molecular structures if you want to, but otherwise I'll let you save that for chem class. HCO3 in water is technically a carbonic acid. So as we breathe out CO2, if we were to breathe into like a straw and blow bubbles in some water, we would actually be creating that acid and making the water more acidic ourselves. If you do it right after you run, you increase the acidity even faster. So the carbon in the abiotic environment, so biotic was living, abiotic is non-living. That is like your rocks, calcium carbonate, limestone, and coral. You guys have a bunch of limestone here in Colorado because this used to be ocean a long time ago. So you have, that's where some of your sandstone comes from as well. But that's like your seashells, things like that get ground down, create limestone. You also have your deposits of coal, petroleum, and natural gas from fossilized organisms, which you do have here, and then dead organic matter, so that humus layer of your soil. That's where it heavily is in the abiotic environment. All right, so carbon enters the biotic world through photosynthesis. So your plants, your algae, your cyanobacteria, you guys should recognize that from last year or whenever you took biology. It also happens through chemosynthesis. That's archaeobacteria where there's no light needed. So down in the Marianas Trench, like the second deepest part of the ocean, so they found one a little bit more deep than that, all there is sulfur vents. So that rotten egg smell is sulfur. That's the thing that takes over when there's no oxygen in the environment, or it's a lack of, and they can't do photosynthesis. No oxygen, no light. Sulfur is the next thing to take over, and that's how they create their food and energy. And that's how you can have like the blobfish. Alright. So carbon gets back into the atmosphere through cellular respiration, burning, like what's been going on at Mount Cameron, decay, which produces CO2 if there's oxygen present, so decay above the surface really. It also produces methane, the CH4, which gives it some of its really fun smells. One thing that would be super cool is there's things called body farms. Don't know, have you guys heard of body farms? So if you ever want to know how a body, whether it's human or whatever, decays in a weird circumstance, you can go to a body farm and throw a dead body out there and figure it out. And yes, that's a job. People get paid for that. All right. So this is called a Keeling curve. It's a graph of the accumulation of carbon dioxide in our atmosphere over the years. So this graph starts in 1960 and goes up to 2020. Although this was an estimate, oh, it did go through February or June 2020, sorry. The measurements are taken at Mauna Loa in Hawaii, and they are still taking it. They have a lot of observations up there, especially because it's not as affected by light and air and all the other pollution that would affect if we were to do something from like Denver, since we're surrounded by so many humans and anthropologic effects. Obviously named after the dude who came up with it. He supervised it until like 2005. Nitrogen cycle is the second cycle. This one is definitely one of the more important ones in this topic as far as environmental science goes, because it's so intermixed with so many other things, including other cycles. This one gets a little tricky. Obviously, you have your food webs. The nitrogen cycle gets affected by fertilizers and crops. It gets affected by runoff. So when it rains and everything runs off into the oceans or streams. You have denitrification, nitrification, and ammonification, which you guys will practice a little bit more tomorrow. I think it's just a picture for you guys. Might be. I think I just put in a picture, but maybe not. Did I grab the right one? I must have pulled up the wrong set of slides. Because I also have the answers, or maybe they're out of order. So the nitrogen picture you guys have is a little bit different. It shows like the factories. Say that again, Leland?
Was there anything else to write for this?
By the time we got home.
Not yet. You guys just have a different nitrogen cycle picture. You'll see it has all the same stuff, like the fixation, the denitrification, assimilation, all of that. It's in there. I just think, hold on. I think I went out of order on here. Yeah, because there's the practice questions. So I somehow.
You have this?
Yes, you do have this part.
Where is this at? Is it below all the
I'm
questions?
sorry. I turned to the wrong page. I apologize, guys. In the thing when I was trying to figure out. Uh, gotcha. We're gonna go through each of these separately, but oops. Ah, Daryl decided to join us today. Um, so there's the healing curve. That is an interactive you guys will work on later. So, sorry. I've been writing another packet of notes and I got confused. All right, so this one right here, you are going to be writing in information um, from those questions, and then there's some practice ones after that. Oh my gosh. Sorry. All right, so I'm going to go back. I put my slides out of order. I apologize. Going to go back to the. Never mind. I'll pick up this a little bit tomorrow. And maybe I'll fix my mistake on my PowerPoint.
The interactive, is that something we do ourselves or?
Yes.
Yes?
Yes.
Okay.
All right. Sorry about that. I'll see you guys tomorrow, and I'll fix my PowerPoint so it makes a little more sense with your packet.
Yo, Miss Peterson.
What's up, Daryl?
Bye, miss.
The reason
Bye.
I
Bye,
wasn't asleep,
buddy.
I promise I wasn't. But I didn't get a notification this time. I usually get a notification whenever somebody starts the meeting. So I didn't realize.